So we are going to talk about something called the Fermat's principle. It's called the Fermat's principle, but it actually should be called the hero's principle because Hero came up with this explanation. So about 2,000 years ago, people were thinking about light and how light travels. And so Hero, he came up with this explanation for the law of reflection. But Fermat reinvented it 1,500 years later. So it's called the Fermat's principle. And this is how it goes. Law of reflection. And this is when light is considered as rays. So we're looking at rays of light. So Hero said, when light propagates between 2 points, it must take the shortest possible path. Does that remind you of variational principle? What does a variational principle say? So you were doing partial over L, remember Lagrangian equals 0? And how do you minimize in math? You always take the first derivative of something and put it equals to 0. That's what he's saying. Okay, so how does that help us? Let's say I'm going to start drawing things. Let's see if I can move it a little bit closer. Okay, so if I have a light incident, I do this color for light. So how does light go from point A here to say point B here? Well, the shortest possible path, shouldn't it be this one? But imagine it can't do that. So it has to have this reflecting surface here that it can take. But which path will it take? Will it take this path or red, that path? Which path will light follow? Of course, this is an over-exaggeration. It should be done closer. But yeah, we all understand this is an over-exaggeration. Okay. So how does light choose which path to take? It could take paths A, C, B, A, D, B, or A, E, B, where this is C, this is D, and this is E. So it can take any of these paths. If light did not have this reflecting surface in the middle, what path will light take? 6, 1, 2, 3, 4, 5, 6. Is this the path light will take? So there's no reflecting surface. The source is at A. Light take this path from A to A prime, say. And of course, everywhere. So, but I'm only talking about this one ray. This is the ray it will take, right? So I'm going to call this surface O. And I'm going to say no reflecting surface. Light will take path A, O, A prime. We also know from geometry, what is the shortest distance between 2 points? A straight line. So then, if the source was at A prime and it wanted to get to B, what path will it take? A straight line. Will that path look like this? So shortest distance between A prime and B will be a line A prime DB, which means that I will never have this happen or that happen, because his principle stated that light will take the shortest possible path. So what is the only possibility left? That goes away and that goes away. That means this all goes away. Ooh. And this all goes away. Which implies that the angle of incidence must equal the angle of reflection.